one, we're going to establish or verify these trig identities. These are going to be your even-odd identities. So you have this negative in here. And here's your properties of even-odd identities here. Now, the thing is, when you see something like this, so we're going to do the first one. This is really tan of theta squared. All right? So basically, when you use your even-odd identities, and I'm just looking at this, this is really going to be, if you have a negative here, that's going to equal negative tan of theta squared. So when you square out the negative, it turns positive. So what we get is 1 plus, because you're squaring that, tan of theta, and then you move that square back in. So you get 1, let me put the square, tan squared of theta. Well, 1 plus tan squared of theta equals secant squared of theta. And so we have this. So the main thing you have to know on these kinds is that we're squaring it. And that these are the same. These are the same. So we have secant squared theta equals secant squared theta. Now we're going to do the same thing for the next one. We have this 1 plus cotan squared of theta equals cosecant squared of theta. So it's going to be 1 plus, for cotan of theta, here it is. So I can rewrite this as negative cotan of theta squared. And it's like, even if you just had sine squared of theta, we can write this as sine of theta squared. We don't do that, so by convention, they put the square here instead. That's just by convention. But this is what it really means. So you can square out that negative and then move this square back inside. You get 1 plus cotan squared of theta. And by our Pythagorean identities, this is when I divide this sine squared plus cosine squared equals 1. If I divide all that by sine squared, I get my other identity here. And this equals cosecant squared of theta. And so that matches up. You can write this again. Depends on your teacher if they make you do that. So we verified both of these identities. Thank you. Have a nice day. Bye-bye.